Okay, so welcome to our lab on the difference of means. The first thing I want to note here is that I've downloaded the lab file from the assignments page on Canvas. I've also made sure that I downloaded the diamonds1.csv dataset and the diamonds_good.csv because I'm going to need both of those to sort of complete the lab. I've also got them saved in the same place. So I'm deep within my file system structure here, but wherever your folder is for this class, or maybe the desktop or wherever you like, but make sure they're all saved in the same place. So we're going to be working with this diamonds data set. The price of diamonds is typically determined by several different characteristics: the cut, the clarity, the color, and the carat weight of the diamond. And generally, as the prices on the diamonds go up as the carat weight increases. But this increase is not so smooth. So for example, if we look at diamonds that have a carat size of 0.99 and diamonds who have a carat size of 1, that difference in terms of the naked eye is totally negligible. It doesn't matter really whether you have a diamond that has this 0.99 carats or 1 carats. They should be very similar in price, but in general, the market sort of dictates that as soon as it reaches that 1 mark or more, they tend to be much higher in price, even when you compare to something that's really sort of nearby the 0.99. Okay, so we're going to kind of explore that idea here. So you just have to run this code to be able to read in the diamonds1 data set. And again, just make sure it's saved in the same place as your lab is, or you'll have trouble. So we'll press the run button, and I can see now that this diamonds1 data set is there. I'll just click on it. There's a preview here, but I think it's easier to see if I just click on it. So this has a list of a whole bunch of different diamonds. In fact, there's 1,500 diamonds here, and we have all kinds of information about them. The carats, what you'll notice here is this data set, the diamonds1 data set, will only have diamonds which have a carat of 1 or a carat of 0.99. We also have information on the cut, the color, the clarity, the depth, the table. I don't even know what all these things are, but I'm sure someone who studies diamonds knows what they are, as well as the price of the diamond. And then I think these are dimensions, but we're not going to use those too much. So the ones you should really be focused on, at least for the first part of the lab here, is the price, okay? And then the carat, right? And keeping in mind there's only 2 levels here in this diamonds1 data set. One thing that we kind of have to keep in mind is that if we want to compare between the two, the 0.99 and the 1 carats, we better work out a standardized price representing, you know, the price per 0.01 of a carat or something, because otherwise, you know, the 1 carat, they definitely have more carats than the 0.91, so it should cost a little bit more, but not a whole lot more. So we're going to talk about this standardized price, the price per 0.1 of a carat. So if I just run this code, you don't have to touch it, just run it, and what you'll notice is when I click on this data set, it creates a new column here called standardized price. And so again, this is the price per 100th of a carat, okay? So the first thing we might want to do is explore the data set a little bit. We often look at side-by-side box plots. So if I run this here, the box plot code says standardized price, so that's always your Y variable or your continuous variable here. So in this case, it's the standardized prices that are sort of a wide range of numbers, right? So that goes first. And then broken down by, we use this little tilde button. You'll find it in the top left-hand corner of your keyboard, okay? And then carat. So this is the one that has 2 levels. In this case, it's 0.99 and 1. I specify specifically to use the diamonds1 data set, otherwise it won't know to find standardized price and carat. The other way that you could have done this is you could have said diamonds1 reference the standard price column and diamonds 1 reference the carat column, that would have worked as well. So I'm just going to go back to the old way, but it's sort of up to you. And then this main command, all that did was add on a title here. Maybe I can make this a little bit bigger so we can look at it. And you can see, comparing these two box plots, the means actually, or the medians there, don't look all that much different. We could zoom in to try to get a better idea, but you can certainly see a big difference in the spread here, right? In terms of the standardized price. So for the ones that have 1 full carat, right, there seems to be a lot of outliers up here, right, where they're getting a high value for the standardized price simply because it's 1 carat instead of the 0.99 carats. Okay, and again, that's not based on there just being slightly 1/100th of a carat. It's actually just a difference between the two because we're comparing the standardized price. So getting a visual guide can always be a good start to sort of explore whether it even makes sense to run a hypothesis test here. You may want to actually calculate out some summary statistics. So perhaps you want to actually calculate the mean for each group. So it's been a while since we've done this, but we did use this tapply command. And so remember, the first argument here is always the numeric variable. So in this case, that's the standardized price. The second argument is always the categorical variable. So in this case, it's the number of carats. There's 2 levels, 0.99 and 1, and then mean is the function that you want to do, right? And so this will spit out when you run it. It spits out for 0.99, this is the mean standardized price, 44.5 something something. And for those that have 1 carat, the price is 52.41. So right from there, we can see that there is an observed difference between the two groups, right? But the question is whether that difference is due to just, you know, the diamonds that we happen to sample between these two groups. We just happen to get a bunch of really high priced ones in the one and maybe a few lower priced ones in with the ones that have less carats. But you know, looking at this difference is pretty big. Looking at this plot, it really feels like there might be a significant difference here. So we might want to conduct a hypothesis test with 95% confidence. I'm going to suggest we do a 2-sided test. So we're going to test the null hypothesis that the mean standardized price of the 2 groups, the 0.99 group and the 1 group, are equal, that there's just the same, against the alternative that they're different. So that's our 2-sided test. I believe we've seen this already in the notes, but let's just go through it. So t-test, right? Again, this is our y variable, our numeric variable. And carat here is our categorical variable. There should be 2 levels, in this case 0.99 and 1. I'm going to specify specifically I want the diamonds 1 data set, or otherwise it's going to be confused because it doesn't see standardized price and carat up here. We're going to specify the confidence level as being 0.95. If you didn't put in there, 0.95 is actually the default. So I could take that out and it wouldn't change anything, but I always like to specify just to be clear. And again, we're going to put in that the alternative is 2 dot-sided because I want to run a 2-sided test. Again, I could take that out because the default for alternative is 2 dot-sided. But if you wanted to do a 1-sided test, less than or more than, greater than, you'd have to add that argument in. Okay, so you'll see that it spits out all of this, right? So a couple of different things. You can see at the bottom the means for the 2 groups are there. That's the same means that we already calculated up here using tapply. You've got your 95% confidence interval, the lower bound and the upper bound. We'll talk about that in a second. And then we've got our test statistic is the minus 2.817. So I wrote that in here. The test statistic is this. It's going to follow a t distribution. You're going to have to know that. You can also sort of tell because it says t is equal to here. So it follows a t distribution with 22 degrees of freedom. You'll notice in this case it's actually 22.951. If you'd rather write that in, that's probably fine too. Comes from, why is it not inserting? That's weird. 951. There we go. So this is using that big beast of a degrees of freedom formula. But if you'd rather, yeah, so that's why you're getting that weird decimal, but it's fine. And this corresponds to the p-value. So this is doing all the heavy lifting for you. We've got our p-value. Your job is to interpret it. So you should be able to recognize that your p-value is less than the alpha. Remember, we said that we were going to use 95% confidence here. So that means the alpha is 1 minus that, or 5%. So this, because the p-value is low, the null's got to go, and we reject the null hypothesis. And then I always want to sort of write a sentence in terms of the context of the problem. What does rejecting the H naught really even mean here, right? The alternative, we have significant evidence for the alternative, right? And the alternative was that the difference in the mean standardized prices for, oh, this is not right. The mean and standardized price for the 0.99 and the 1.0 carat diamonds is significantly different from 0. Okay, and I specify the amount of confidence. And I'll take that sentence right out. Difference in mean standardized price for these two groups is significantly different from 0. They're different, got it. And then you could also look at the confidence interval and conclude that we're 95% confidence that the true difference in population mean standardized price is between those two values, right? So for two sort of comparable diamonds, right? If we take the difference between them, we expect it's going to cost between $2 and $13 more per hundredth of a carat to buy one that is 1 carat compared to one that's 0.99 carats. And you can decide for yourself whether you think that's worth it. I'm sure that there's some people out there in the world who thinks that's worth it, and that's great. And there's other people out there that might not think that's worth it. So that's not for statistics to tell us. That's more of a judgment call. But there is evidence here to say that that difference is significantly different from 0. So for the rest of the lab, you're going to use this second data set, diamonds underscore good. And so I've essentially taken that diamonds data set. Let's just read this in so you can see it. So again, make sure diamonds underscore good is saved over here in the same place as your lab so that it can read it in. And if I look at it, let's just look at it for a second. This is the data set, except I've only pulled out rows here that have good and very good for the cut. And so you should go through and you'll be asked a bunch of different questions about the good group, the good diamonds, compared to the very good cut diamonds, and compare their standardized prices as well. So that's also where this code comes in to calculate the standardized price in that diamonds underscore good data set. So you've got some problems to work on there. Best of luck.